All right, so we are learning 8.3. And objective of today's lesson is solve trigonometric integrals involving powers of what? Sine and cosines. When you just have a sine by itself, you know what to do. You know what to do when you cosine by itself, or when you have a sine and cosine together, what would you do? That's what we're gonna learn. So this is another what? Algebra manipulation. That's what we're doing. Okay, so we're gonna manipulate the algebra so we can do the problem. That's something you have not know how to do it, but you will learn today how to do it. So the form would be what? Like sine to the n power and cosine to the n power. Okay, m and n is some positive number. Okay, some positive integer. So now let's look at that. They gave you guideline. That's nice about guidelines. They give you guidelines. So you can look at this guideline to figure out, okay, which one should I use? Okay, so guideline says, if you have sine, okay, the sine is odd number. It doesn't care about the cosine. Are you with me? When it's sine is odd number power, they want to break that into what? Convert to the what? We're gonna convert that into cosine. Okay, you're gonna leave only one. One of them you're gonna leave it, but the even number you're gonna make into cosine. Okay, I'll tell you why. Okay. So next one, if you have a cosine is odd number, you're gonna do opposite. You're gonna make that into sine. Okay, so we can do the U substitutions. Okay, and then also you can do this. If you have a sine square, okay, you can reduce the power by doing this. 1 minus cosine 2x divided by 2. If it's a cosine square, you can reduce that power by 1 plus cosine 2x divided by 2. So this is a trigonometry kind of like identities. They're calling reducing power because you use the sine used to have a square power. But when you do this, what happens now? Cosine only has what? 1 power. So you reduce the power. When you reduce the power, you know how to take any type of derivative. This kind of stuff is much easier when I show you examples. But I want you to, okay, kind of memorize this, okay? The sine square plus cosine square is equal to what? 1. Okay, that identity you need to memorize. And we use that all the time. And tomorrow I'm going to talk about secant square is equal to tangent square minus 1. Okay, things like that you need to kind of know this. The Pythagorean identity, you need to know this. Okay, so first example, if I give you this, sine to the fifth and cosine x. All right, which pattern does it match? Remember there's 3 patterns. The first pattern is what? Sine is odd power. Then what do? You make it into what? Even power, and then what? 1 odd power. The reason is I want to use what? Pythagorean identity. Are you with me, class? So that's what we're gonna do. So first thing, you're gonna change factor to use as your u. Okay, because we're gonna do u substitution. Are you with me? So sine fifth. Okay, sine to the 5 power, then which means what's a fifth power? It's a well, it's an odd number. So we're gonna definitely use that. All right, so we're gonna use u to be sine to x. Is everybody with me? Okay, now then what is du? Okay, that's exactly right. So cosine x dx. Now let's just replace it with a u substitution. So I'm going to rewrite the sine as what? U to the fifth. And cosine dx is the same as what? Du, right, class? Right? You figured out u pattern match. You said u needs to be sine x. So du become a what? Cosine x. So you found this. So now just put it back into what? You replacing x with what? U. So you just do a u substitution. So now you simply have u to the fifth du. That's a power rule, isn't it? You know what to do. What is that equal to? This needs to be 6, isn't it? Your answer is correct, but this part is wrong, right? I'll update it for you guys. So that'll be u to the 6 plus what? C. Now what do? You replace u with what? Sine x. So your answer is sine to the 6 of x plus what? Oh, sine of 6 over 6 plus what? C. Then you're done. So look at this. You guys recognizing what to use and what. When you have a problems like this, did you see it? Problems like that? You do use substitution on which one? The one with the higher power with odd number. Okay, but now let's look at something else. This one. This is like a question that you're asking. Okay, sine to the 3rd power and then what? Cosine to the 4th x dx. All right. So check the power given sine and cosine, apply the guideline again. So according to guideline 1, the emphasis on what? Odd power of sine or cosine. So which one has odd power, sine or cosine? Sine, okay. So since sine to the 3rd has the odd and positive power, so I'm gonna rewrite that one, okay? So I'm gonna do the algebra manipulation. So I'm gonna rewrite the sine to the 2nd power and then sine to the what? 1 power. Is everybody with me? Right? So I have a 3. So I make it into a 2 and 1, right? That's 3. So that's kind of stuff you need to learn. You need to know how to manipulate. All right, now we're gonna use Pythagorean identity. So this is a part that the question that you asked me. So I'm gonna rewrite sine squared as what? 1 minus cosine squared x. That's a Pythagorean identity. Okay, so remember you had a sine to the 3rd x, and you rewrite it as what? Sine square of x times what? Sine x. So we're replacing the sine square of x with what? 1 minus cosine square of x. So that's what I did right here. Are you with me now? And then you're gonna do what? You have a cosine square and then sine x, that just remains same. Okay, now what do? You distribute it. You distribute this into here and that over there. All right, are you with me? So now what do you have? So when you distribute it, then you get a 1 time cosine to the 4 and sine x, right? The other one to be what? Cosine square times cosine to the 4 times sine x dx, right? I simply just distribute it. Everybody with me? You have cosine 4 sine x. Distributed to here, you get what? 1 times cosine to the 4 sine x. What's the other one? This times that gives you what? Cosine squared times cosine to the 4 and sine x dx.
What times what gives you that? Can you circle the terms that you just distributed? All right, so
you're distributing that into where?
Into 1 and cosine squared. So cosine squared. Oh, I see it now. I see it. I see it. It's cosine squared x times cosine to the 4th.
Did you everybody see it? That's the reason I put the green color here. So if you want me to, I can probably change them to green colors. You can see better. Okay. But does everybody see it? I see. You follow me? Good.
It's just the distribution. I was trying to see how you just used it out, but I see now.
You see it? Okay. So another thing I can do, I will probably update this for you guys and change this into green color. I make this into green color so you can see that is a distributing. Remember, like I put the green color here, so I make it into green color so you can see easily. Okay. Now, after you do that, I want you to make it into 2 problems. Okay. Of course, you can combine them too. So you have this as 1 problem. Okay. It's what is another problem? You have a cosine squared times cosine to the 4. How many power is that together? Cosine to the 6. So you have a cosine 6 and sine x dx. So you have 2 problems. Okay, are you following me?
Oh,
Just look at this. This is just a simple mathematics.
I see.
Cosine x is 1 times this is just this, right? And this and that combined to be what? 6 power and sine x dx. But I want it to, since it's just connected by negative, I can make it what? 2 integration problem. So taking this, you know what to do. This is just like the problem 1. I'm going to make this to be what? U. Okay. So you're going to make this to be U. U equal to cosine x. And du will be what? Negative sine x dx. Are you following me? Okay. So you got a u to the sine x dx, u to the 5th, and sine x dx. So sine x dx is the same as what? Negative du. And negative sine x dx same as what? Du. So now, this right here is negative u to the 4 du. This becomes what? U to the 6 du. So now just do the simple what? Power rule. Then you get u to the 5th divided by 5. The 7 divided by 7 plus 6. Now you just what? Put it back and do substitution. You get a what? Negative cosine to the 5th power divided by 5 plus cosine to the 7th power divided by 7 plus 6. And you're done. Okay, so this lesson 8.3 has a lot of algebra manipulations, but it's not that hard. Okay, it's just longer. Okay, it's not harder, it's longer. Okay, so it's not harder. So let's look at one of the easy ones. So this one is an easy one. Wallis formula. So there's just like the lesson 8.2, they gave you some patterns. They figured out. So you don't have to do this. You don't have to calculate. You just plug in the formula. So the Wallis formula says if n is odd power and n has to be greater than 3 of integration between 0 to pi over 2. It's only this is true. Okay. The Wallis formula does not work for other ones. Only works between what? 0 to pi over 2. Then if it's a cosine or sine, okay, doesn't matter, it's a sine or cosine, they figured out this. 2 over 3, 4 over 5, 6 over 7, all the way to what? Whatever the n minus 1 power is. Okay, so which is a very good one. Okay, so look at this example.
So for that one, n would have to be greater than
3.
or 6 or 7 too, right? Because the way the fractions work. You scroll up. So like, since we have 6 right here, like n, so that's fair.
Like, any n greater than 3, greater than equal to 3. So look at this problem. Can I use the Wallis formula for this problem? Yes. Why? Because this is a 0 to pi over 2. Okay, and it is cosine to the 7th power. 7 is bigger than what? 3. Because this is like 3 or larger, you can use this. All right, now looking at this. So let's just use the formula. So the formula says starting with a 2, right? Start with a 2 divided by 3, 4 divided by 5, 6 divided by 7. I'll stop at 7. Why? My n is what? 7. So I stop at 7. Okay. So that's easy. So this one you can just add all together. So on your exam, you can just stop it right here. I will take it. If I give you this problem, you can stop it right there. You don't have to calculate this part. Doesn't really matter for me. So
like
right. So if it's a even power, yes, right. That's exactly right. And it's even power, you can start with what? 1. So in other words, if you have 0 to pi over 2 and cosine to say 10 x dx, what can you do? So Kobe, tell me, what do I need to do? Start with what? 1. 1 over what? 2. And then what? 3 over 4. 5 over 6. And then what? 7 over 8. 9 over what? 10. And then what do you do? And then multiply by what? Pi over 2. Yeah, that's your answer. Is it easy? Yes. Wally did a lot of work for us, definitely. All right, it's a pattern. He figured out. That's right.
It's just cosine.
Sine and cosine. You can do the both of them. So you can use this one for what? Sine and cosine. But make sure your boundary is only what? Pi over 2 to 0. Okay.